let's find out gradient of a scalar. In 2D system, 2D coordinate frame, x, y are the coordinate axis. This point has a particular value of set of values for x, y, so let's call it x, y. This point is having another set of values for x, y both. So this is x dash, y dash, for example. So the distance between, if a particle travels from this point to this point, then the distance traveled is যে দূরত্ব অতিক্রম করবে is r equal to root over of x dash minus x whole square plus y dash minus y whole square. And if we want to find out, if we want to write the vector r vector, so it would be r vector, it should be equal to I cap x dash minus x plus j y dash minus y. This is the length of this r vector. Similarly, if we have a 3D coordinate system like this, I can show a particular point having coordinate x, y or z because this is a 2D plane. So let's take a point here and let's take another point which is more close to our lens. It's getting hazy. So this point is having a coordinate set of values x, y, z. এই পয়েন্টের coordinates হচ্ছে x dash, y dash, z dash. So like 2D, we could write for length of the distance should be equal to this, and this is the vector itself. This is the length of this vector. So r square is this. If we want to find out the gradient of this scalar quantity r square, so we need to just operate del del x on this, del del y on this, del del z of this, on this, because this point is not having a mixing of x, y, z. There is only one variable on the first term, which is x. So operating del del x on this and this will just give me 0. Del del x অপারেটরটাকে আমি এটার উপরেই কাজ করাতে পারবো, এটার উপর আর এটার উপর অ্যাক্ট করলে it will give me 0 দিয়ে দেবে। তাই del del x is operating on this only and del del y is operating on this y term. Similarly, del del z is operating on the z term. After some differentiation, we have arrived at this point. So if I can take 2 outside, so this is left in the parenthesis. This is nothing but the vector r, which is a distance vector between x dash, y dash, z dash point and x, y, z point. So we could write it as 2 of vector r. Now if we think of an 1D function, suppose we have x square. If we just make its derivative ddx, so we know that we have this. So the thing is the same here, just it is in 3D and r is having all the 3 coordinates x dash, x, y, z, or maybe x dash, y dash, z dash, because that's nothing but just a change of notation. If we are done with this, the gradient of the scalar, then we will be readily find out this gradient of 1 by r, which should be equal to r cap by r square. Let me recall you that r cap unit vector is equal to vector r by its length. Hence, but one more thing I would like to mention, that you may find a minus sign here. That I will discuss in the comment section, and we will be readily able to find out the del of r to the power n, which is a more generalized form, and this will turn out r to the power n minus 1 to r cap in r to the power n minus 1 into r cap